Morning, everyone. How are you? Buddy. Good. Today is our last training section. Uh, the wiring, the last stage, as I told you. Or we start. Uh, I already sent to you the video yesterday. I finished the wiring in the station. I created everything. I placed the component, made the wiring to check. I made some updates. The test project. I already update you on our WhatsApp group and email in our share folder. The change I did is just because we don't need one piece of wood of 1 meter, 1.2 meters. I could manage the components in 80 centimeters per 50 centimeters. It was enough. It's better because I have to move from each emirate during the skill challenge. So as smaller as possible, will support me during the process. Today, I'll explain you about the wiring, just an overview about the connections, what are the standard expected from the competitors, and I will answer your questions. I sent this video that I recorded yesterday to you. I will go step by step with you to show you the wiring, the standards that I'm expecting during the competition. The first part in the left side, as in our layout, we have the solar panel. The solar panel will be placed ready for the student. The first connection that we have is the solar panel and the fuse, according to the diagram I shared with you. And here, I would like to explain you. As our solar panel is plug and play, it means you connected it and is already working, already supplied. I will let here two connectors for the competitors. The competitors will just connect the wires in these connections I let here. These two connections I let here. The competitors, they will not manage directly in the solar panel. Just for make them safe and to make sure that they will not damage the connection in the solar panel, because the solar panel uh, is very sensitive, so it's very sensible, so it can break during the operation. To make sure that they will not break it, they will just make the connection through these two connections I let here available for them. Yes, Mr. Mohammed.
Yes, Julian. Can you go back to the solar? In the diagram, it was there is a wire for the earth, but here I can see only two wires.
Yeah, we don't have the connection for the earth here. We can manage it here, but I think it will be a lot of problem because this is plastic. This is not metal as I was expecting. That's
Yeah,
why I
yeah, I
didn't add it.
understand, but يعني, but this difference it's not a big deal, يعني. That's it.
Yeah, yeah, yeah.
Okay.
So don't worry about it. If I see that we have to make it, but I think that all kits I received, I just opened one box. By the way, I already prepared the material. I already requested Lois and Hamdam to send it to you. So next week, Monday, Tuesday, maximum, they will send it for the schools that the skill challenge will happen. Maximum Wednesday, you will have the materials there for you check and see the connections, how the components are, and etc. I'm not sending to you just the protection for DC. You can use any circuit breaker you have there just for your practice, because they didn't buy many, because the one we found here was very expensive and we need 6 per kit. So we should ask so many and we can replace them for circuit breakers. In the competition, we'll have fuse carries and fuse, but for you train, you can use just circuit breakers. The connections are exactly the same. They will not change. You have to use bipolar circuit breakers because we have fuse for the positive and negative as the diagram we created
So you
last
will not
train.
send the only missing thing from the kit is the fuse, William.
Yes, I'm sending the distribution boards, I'm sending the solar kit panel with the inverter, the charger, etc. I'm sending the socket, the box, I'm sending the trunking, circuit breaker, power surge protection, RCD, everything I'm sending. Just the fuse carriers I'm not sending because we don't have enough.
Okay.
But it's not a big deal because you can replace them for 3 bipolar circuit breakers to train. Okay,
Okay.
good, good, good. So keep going. So the connection here is okay. Let's keep going. Inside our distribution board, the first one is for the DC protection. So here we have 6 fuse carrier. Uh, as I told you, you replace it for bipolar circuit breaker during the training. The connection here, it's not labeled yet because I requested them the label. They brought the machine, but what happened, the refill of the labels finished when I was labeling. So that's why I didn't send you a picture with the full label done. I will do it on Monday because I requested them yesterday to buy the labels, and I will do it on Monday. On Monday, I'll send you a picture with all labels placed for you see what I'm expecting from the competitors. But here, starting from the left to the right, is Fe1 plus, Fe1 negative, F2 plus and negative, and F3 plus and negative in the sequence. You just have to follow the drawing. The connections here, the competitors must do here inside. They have to prepare the wires. The wires must be tied, organized, aligned. I'm trying to provide cable ties, but I didn't receive yet. When I receive it, I will finish here the connection. I will show you using the cable ties just to organize the wires inside the panel. Of course, the student, maybe they will make a mistake or they will pass the wire in a wrong position, but train them, guide them to make it as organized as possible. Make it organized as possible. Because this is included the board, the main distribution board, DC and AC. The organization inside makes part of the marking. Keeping going here, we have the AC board and our socket. I will provide to them during the competition the ferrules, the yellow components here that we place in the wires to make sure that there will be no couple exposed. So you can see that just the plastic part you can see. You cannot see the connection, you cannot see metal, even couple. This is the best practice. This is what we are looking for. If the student let couple outside or the metal part visible, marks will be deducted because it's related to the safety in the installation. Same for the distribution board. See, no metal or couple exposed, just the plastic, just the insulation. This cable with the socket, I will let it prepared for them. This is the picture number 2. Yes, this one. I will give for each competitor the plug connected to a cable and connectors. For the student, just connect here, the line, the neutral, and the ground. Here. The student does not need to assemble this cable with the plug and etc. I will provide it to them. They just have to connect them here. Same for the battery connection. For the battery connection, I will supply them with these 2 wires with the connectors, and they just have to connect the wires in the connectors. Using the connectors, having in your mind that the competitors, they don't need to use ferrules. By the way, I advise you don't use ferrules in the connectors. Because if you use ferrules in the wires and try to connect here, maybe the wire will not fit because the ferrule increase the size of the wire. So the competitor, the student, must to connect the wire without ferrules. Keep going here. This, I forgot to take a picture of this wire as well, but the connection in the inverter with ring connector, with ring terminals here, I will provide to them as well. They just have to make the connection through the connectors inside the trunky. All the special connections will be given to them. They just have to make connections using ferrules inside the distribution board, inside the distribution board AC, DC, and in our controller here, charger controller. This one here, yes. This one they have to do because this is using ferrules that they have to prepare it, using ferrules with crimpers and etc. Again, no couple, no metal exposed, just insulation appearing. I can see just the insulation. And that's it. There is no secret. I try to do my best to keep it as simple as possible for make sure that our student will be able to perform, to make the wiring, to prepare everything, and deliver the job during the 4 hours with the project and with the drawing. Okay, Uma has a question, please.
Yeah, William, these wires, the length of the wires, the student have to cut by themselves or
Yes, they have to
okay.
cut by themselves.
And the ferrules are provided during
Yes,
that.
yes. I will provide around 100 ferrules per each competitor. It's more than enough.
Okay, thanks.
Okay, welcome. Mohammed, please.
Yeah. Thank you, Liam. Just I understand the whole circuit. It's very easy. The only part is a little bit not clear, except circuit breaker is the DC protection circuit. Sorry, the AC. I'm sorry, not the DC. DC is piece of cake, but the AC.
Okay.
Can you explain these components starting with circuit breaker
Yeah,
to the
sure,
right?
sure. Yeah, go ahead.
Yeah, and the purpose of each component, and if you can relate it in the diagram so we can understand the concept and the reason why we added here.
Okay. So let's go. Let me just open the yes. For the AC we have F4, the bipolar circuit breaker. This is the main switch. Okay, we're gonna protect the circuit against short circuit through this circuit breaker here. This circuit breaker is connected to our surge protective device. A surge protective device protects the installation against over voltage. So, for example, in a real application, against lightning, against a high voltage. Imagine let a high voltage wire touch the low voltage wire, and the voltage increase very fast in the system. So the surge protective device will make a kind of short circuit and drain the current to the earth. That's why we connect it in the ground. Will drain this current and will make sure that the voltage in the system is not higher than the safety voltage for the circuit. In the case that
So
you have
surge protection is for lightning and overvolts, maybe two phase we will receive during the
yeah,
operation. Yeah,
perfect.
that's clear.
That's it.
And we are using the first one, the double pole circuit breaker, to protect our circuit from short circuit. Correct?
Exactly. A short circuit
Oh,
that can happen inside the board here, especially.
inside the board. What about the third one?
Yes, the third one is the RCD, residual current device. This is to protect the user in the installation against shock, electric shock. This component works on this way. The current that's going inside in the line is the same that the current is going out in the neutral. So when we sum them, we'll get zero because they are in the opposite way. The magnet field inside is neutral. when someone get shock or something like that, what happened? The current flow through the ground, not through the neutral. And automatically this device will shut off the system. So it protects against electrical shock.
Amazing. Last one, circuit breaker for what?
The last one is a single circuit breaker. This circuit breaker is just to protect the socket. So our socket outlet is connected directly to the circuit breaker. If you make a short circuit in the socket outlet, this one will shut off the circuit and not the main one. The main one is to protect inside.
The main one is connected to what, Williams?
The main one, the bipolar one, is connected to this surge protected device and the RCD. The RCD is feeding the single pole, and the single pole is feeding the socket.
One more question. If you can see the socket, you have the
Yes.
color green, blue, but we have yellow. It should be brown, correct?
Yeah. Because I don't have yellow available here, and
You mean you
yesterday.
don't have brown?
Yeah, I don't have brown here. I used yellow by this reason because yesterday
So
I tried to
the
finish
student,
fast.
yeah, the student will lose mark if they're not following color code, correct?
Yes.
So, for
But-
example, if you can check the wire in the top here, power inverter, you can see it's red and black, and there is a lot of red and black for the battery also. These all should be brown and blue, correct?
No.
Or not?
This is DC, so it should be
DC,
black
أيوة.
and red. Yes.
So DC connection, black and red. That's
Red.
great.
Yes. Anyway, in the case they don't deliver me the brown one, I can use the yellow. I will inform the student, but the point is they will get 5 different colors. 2, black and red will be for DC circuit, blue, green, and the third color will be for AC circuit.
What about the connector, William? You'll provide, of course.
Yes, I will provide them as well. I will bring, I think I designated 10 per competitors, more than enough.
Okay, and this connector will be like a junction. I can see you can connect till 4 wire at the same time in the same junction, correct?
Yes, 3 wires. The one
3
that I
wires,
would,
okay.
yes, 3 wires in the same junction.
Excellent.
Yeah, that's it.
So total, there'll be 5 connectors in overall. It's applied for
5.
this project.
No, we're going to have 2 here for the solar panel. Okay. We'll have 2 for the battery,
Okay.
2 for the inverter. So 6 plus 3
For the AC.
for the AC connection. Yeah, so 9.
Okay.
I will give them 10, but
Mhm.
1 will be extra just in case they break it or they lose it. They have 1 extra.
Mhm.
William, are you going to provide the connectors in the kit that you're going to send?
No, I don't have connectors. By the way, I don't have connectors to assembling the kits. I already requested, but they didn't deliver yet. So I will not send the connectors. You can use any kind of connector you have there.
Mm. And
Okay.
again, what does the what does the SPD feed? The socket and what?
SPD?
Yeah.
SPD doesn't feed anything. The SPD is a protective device.
No, I
In
mean
case-
from down, you connected it to where?
To ground.
To the ground?
Yes.
What ground? Yani, you mean to the socket and what? Where?
Just to the socket. It's connected
Just to the socket?
and the plug here.
Okay.
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 Because in case of using it, of course, I created a kit, I will move it. But in a reapplication, I should connect this ground in the ground of the installation, or to create a new ground for the circuit.
Yes.
Here is just for the student, they practice and show that they how to connect the protective devices in the circuit. By the way, during the competition, as is mentioned there in the test project, the student, they cannot connect the solar panel during the test, even the battery, to make them safe. That's why I will just provide them the fuse when they finish the wiring, to make sure that they will not supply any component during the work. It's mentioned in the test project.
Yeah, William, one more time. I know Miss, she just asked the same question, but
Mhm.
yeah, you have a lot of ground earth in the diagram, and here I can't see where it's going, the
Okay.
connection.
We have one that comes from the inverter. This one
Okay.
here. Okay. I come with this wire and connect here in the output of the SPD. I go out
Okay.
from SPD and go directly to the socket outlet. Just two connections.
Yeah. What about the earth and the DC?
DC we don't have because, as I told you, we should protect the solar panel if it was metal and our inverter, but both of them are plastic, so we'll not connect the ground on them.
Okay. So the student, when they draw the diagram, they will not put the earth for the DC and for the solar cell and of course the charge controller.
Yes.
So only for those you had here in this video.
Yeah. I will try this week because what's the point here? I didn't connect because in this case we don't have ground, but in project it's good they let available the ground. By the way, I will check if I have ring terminal here. For they let the ground available. They don't need to connect, but let the ground available because imagine we have to replace the solar panel. We have to have the ground available there.
Mm,
Okay.
okay. Can you go back to the AC circuit?
Sure. I will update with, I think they will deliver me on Monday, the ring terminal. I will prepare the ground for the DC part and I will share with you on the WhatsApp group.
Inshallah. Now, in the normal system, from surge protection, I
Yeah.
should have another third wire connected to real earth in the system. I mean the copper rod in the ground.
Yeah.
Correct?
Yes.
In the real system. But here, because we don't have this copper rod, we did not connect it.
Perfect.
خلاص. Excellent.
That's
Thank
it.
you.
That's it.
That's
You're welcome. Very good. That's it. So the pictures are already in the our shared folder, the video as well. On Monday, when they deliver me the ring terminals, I will make the ground for the DC part and I will share with you the picture. But basically, what I'll do, yes, we will just let available here one ground connection and just let available here another ground connection. The competitors, they don't need to connect them because the components are plastic. But in case we replace them for metal components, the ground is already there. And they have to mention it in the project. By the way, the drawing I shared with you, it's there. Yes, Ms. Sally? Ms. Sally, you raise your hand. Yeah, sure. I saw here in the, no problem. I saw here in the message in the chat. Yes, I can share with you the specification of this connector. It's a Vago connection, 3 connections, but I will share the specifications and one link in Amazon or any website for you see the component itself and the specifications. Just let me make notes about it. I don't forget. Specification. And ground DC connection. Very good.
William,
Yes.
Is there any sequence in the wiring? For example, normally we cannot, shouldn't connect from the PV to the charge controller first, right? So is there any sequence in the wiring? I mean, we should do like charge controller to the battery first, or is there any sequence or?
Yes. Our training session number 1 was about the drawing that the student must do before start the wiring. On the diagram, on the drawing that I shared with you, you have the sequence there. I think I add it in our shared folder as well. Give me a second. No, it's not here, but I'll share with you. I have it here.
If you can share it now, we can save it,
Yeah,
William,
yes.
right away.
Yeah, I'm opening it. Just 1 second. Skill challenge. Test project. Previous. I mean, this is the sequence. Here's the sequence. Oh, by the way, I forgot something that I'm seeing here now. We have to let available the ground for the distribution board as well.
Yes, I was talking about this, William.
Yes. You are right. I will update it on Monday. I will share with you. And I will let me close. Let me copy. And
William, can you
place.
explain the sequence here, please?
Yeah, sure. First of all, we have the solar panel, what will be our supply element. And in the C distribution board, we have the fuse care F1 plus F1 minus. They will feed our PWM charger regulator. So 2 wires will come out from the regulator, will go to F2, positive and negative. And after that will be connected in the battery. In the same point, you have to make a junction here and connect F3 plus and minus, and we'll connect it in the power inverter. So this is the DC connection. On the right side, we have the AC connection. So we have the line, neutral, and the ground. We have F4, that's a bipolar circuit breaker to protect the entire circuit. We have the surge protective device that protects, again, high voltage in the system. We have the RCD that will protect against electrical shock. And F5 will feed the socket outlet, will protect specifically the socket outlet. This is the sequence.
William, I have one question only. From the
Yes.
surge protector, right? If there's any overcurrent in the main wires, right? See, this extra current will be sent to the earth ground, or because your connection, you said that you connect to the socket and also to from the inverter.
Yes. The
But this
surge
ground,
protected is not to protect against high current, is voltage. If the voltage increase, the surge protected device act. But if the current increase, the circuit breaker will act.
that grounding here in the diagram, it goes to where? Which ground
Yes.
are you made? Which ground is
Yes.
that?
This one here.
Yeah, but that is connected to where, Williams?
Basically, our ground will be connected to the solar panel I will add on Monday, our regulator to charge the battery, inside the panels, AC and DC, and connected directly to the socket outlet. We will not connect it in one external ground, just internally in the kit, just for the student show that they know how to connect protective device. Okay. That's why I will not provide them the fuse during the assembling, the wiring process, to make sure that they will not connect the circuit and be in a dangerous situation. I will provide the fuse just when they finish, and then I will test it.
Okay, one more last simple question. Normally for all the breakers, circuit breakers and MCVs and all that, right? So the inlet is from the top and the outlet is always the procedure. The in is from the top, right? And the outlet is from the bottom. They should stick to this.
Exactly, yes.
Okay.
they have to follow this standard. So again, this one is provided to you. I'll place it in the shared folder just now. So in test project is there in module 1 installation diagram. It's in Portuguese. Let me change it to English. Installation diagram.
So William, you mean that the students need to do the drawing, the farm project, and last thing is the installation? Because
Yeah. The order, they can choose it, but yes, the drawing must be done before the wiring, because
Yeah,
doesn't
sure.
make sense. But if they wish to make the project before start the drawing, they can.
No, I mean because you're not going to give them provide them the fuses until the end, so they have to do the AC part before the DC. That's what you mean?
No, I mean the end of the wiring. When they finish the wiring, you provide them the fuse.
What wiring? Because for example, when they want to connect the regulator, they need the fuse. If they want to connect the inverter, they need the fuses.
No, to connect they don't need. To test they need. To connect they don't need it. They will connect it through the fuse carry. I mean, here, because the fuse will be inside here. So they open.
Okay. Yeah, okay.
Did you get it?
Yeah, I get it now.
Okay.
William, Miss Sally is asking you to read the chat.
Oh, yeah, I see here. Share with us also the shape of the fuse is going to be used. Yeah, it's in the infrastructure list, but I can share, yeah. This is a problem because I didn't receive them yet. It will come on Monday, but as soon as I receive them, I can send you a picture. The fuse is in our list is 10 per 38 millimeters, 2 amperes. This is the size. The infrastructure list, we have it there. But yeah, I can send you, no problem. I send you a picture.
So Williams, coming back to the diagram, right? So the
Yeah,
students, they need to bring their stationery to draw exactly, use ruler and pencil or ruler.
Yes.
Exactly. So they should replicate the same drawing as it is as shown. So they have to remember every, symbols and components that need to be used. Basically,
Yeah.
just reproduce back the same diagram, right?
Yes, but they don't have to do exactly the same. They just have to follow the symbols. If they follow the symbols, the position as they are, there's no problem to me. It's not a problem. Because the most important are the connections and the components. That's it.
And the labeling also, right? F1,
Yes, sure.
everything. Okay.
Yeah.
Yeah, and let's say, William, if they would like to draw the battery, no need to draw the actual battery inside the box. It's enough to write 4 for the labeling and 12 battery below it. That's it.
Yes, that's it.
What they need, only simple rectangular shape is enough.
Yes.
For the
But
battery,
for example,
solar
for the
cell,
circuit breakers, for the fuse, and the AC inverter, and the solar panel, they must follow these standards because these standards they are requested. But for the regulator and for the battery, they can choose.
yeah, they can just draw a simple
Yes.
rectangular shape. Okay.
Yeah, and maybe right inside battery 12 volts plus and negative, and that's it.
Okay, regarding to this, good morning, everyone. Regarding to this, Mr. William, the symbols for the battery or the type of it, like B4, something like that, regarding to the booklet that you send to us, they should write the type of the battery itself as an example, or the PWM charger type, or just PWM charger regulator.
The labeling.
The labeling.
Just the numbers. So the BMW
numbers.
chip, just place 5 there for me is enough.
Not the one we bought like BM4L something. We have some abbreviation for the type, like 350, something like this.
If they put it, I will not. There's no problem to me. I would just ask them to have a specific label, especially the number. If the 5 is there, if they use, for example, BF5 battery 4 for me, there's no problem. I will look for just for number 5 because it's this number that we have in the table in the test project.
And this is the diagram they have to train how to draw.
Exactly.
Okay, thank you. Thank
You're
you.
welcome. Good. So I will send you the specifications of the connectors. I will finish the grounding connection when I receive the ring terminals on Monday, and the labels on Monday as well when I receive them. Oh, yeah, that's it. And the fuse. Send the pictures of fuse and specification. Okay.
So, William, in Align, there are two schools here. One is TBMC, another one Akabia.
Yes.
So I think you will send the kids to the hub, right, which is in Akabia.
Yes.
My students from TBMC, they can go there and practice how to do the wiring. So,
Yes.
so the boards, the actual size of the board, the solar panel already fixed on the board, and most of the charge control is already fixed on the boards, huh? Only they have to practice wiring. Am I
Yeah,
right?
actually, they know the components, because I will not share you the board itself with you. By the way, I didn't receive yet. The wood I used for this one I recorded was one I found here in Adipoli. They didn't buy
see.
yet. For the kids, I will create for the competition. But you can just place the components on the tables just for them see how to connect, because the most important connection that they have to take care with the organization, with the position, is inside the boards. Inside the boards, you can place them in your bench or anywhere to make it.
But the students have to drill hole in the trunking also, right? So
No,
they
no,
have to.
no. I
No need?
will provide everything, the structure
Ah,
done for them. They just have to make the wiring.
I see. Okay, that's great. Yeah, thanks.
Okay. Does anyone have any question? Okay, if you don't have question, I will provide on Monday to you this the specification for Vago. I will send now. The specification for Fuse I will send now. And on Monday I will share the labeling done in the station, as I will require the competitors in the skill challenge, and the grounding connection for DC when I receive the ring connectors. If you don't have any question, that's it. Thank you very much for participating of the trainings, making questions. It's a new skill, even the word skill, so it's new for everybody. I'm trying my best with the expertise and experience that I have in electrical installation, industrial control, and work in the industry with solar systems and renewable systems to share with you my experience and do the best, especially for the competitors, because the purpose of the competition is for our students show their skills, show how they are growing up and how high level they are during the competition. So that's it. Thank you very much.
William, I have this. Sorry, William. I have just one last question. I saw
Yeah,
the
please.
irradiation diagram. The
Yes.
irradiation diagram. So it's a bit. There is like a range, you know. So in Align, I'm not sure to select 6 or 6.2 because the colors seems to be like in between. So
Yeah.
Can you check for me, please, which one?
Regarding this, I understand that the colors can be different for each one. That's why we have a range. But you see that if you change 0.1, 0.2 will not have a big impact in the end.
I see. So
So
6 and
that's
6.2 is not much of difference.
yes, and that's why I asked the competitors to keep the calculation and the paper, because I would check step by step of the calculation and see the final result, not just check the final result.
I see.
Okay,
Okay,
but for
thanks, William.
example, I imagine that Elaine is 6.2 and the student choose 5.6. Doesn't make sense. Do you get my point?
Yes, yes.
Okay, good. But don't worry about it. Make sure that you are using as near as possible the color you are seeing, and that's it.
Okay, thanks.
For us here in Al Ain, I saw that it's 6.
Yeah, it's okay.
Yeah. Yeah, 6.
Okay,
I
then
I
let's
I
stick to
يعني I
six.
thought maybe it will be 6.1 because it's in the middle between 6 and 6.2.
Yeah,
But I
to me
just
it's
asked,
6.1.
is it 6.1?
Yes.
Okay.
Okay, all
But
right,
if the
thanks.
student use 6.0, 6.1, 6.2 again, just keep the calculation there. They will not be reducing their marks for that. I will not reduce the mark from that.
Again, Mr. William, the kits will be provided within next week, right?
Yes.
Okay, I hope that in order to get full time for training the students, but you have lots of connections there.
Yeah. From my side, the components, they are already separated here. We just need to ask the company to deliver it to you. But it's not in my hand. I just raise it for the organization and they will provide. They promised to me that maximum Tuesday, they will deliver it to you. So I'm expecting on Wednesday, but I think maybe Monday, Tuesday morning, it will be with you there.
Okay, we hope that. Thank you,
Yeah.
Mr.
You're welcome. And I will keep following up with them to make sure that they deliver it on Monday or Tuesday.
Mhm.
That's it. If you don't have questions, thank you very much for participating of the training. I will the record I will share it with you. So if necessary, you can come back and watch it. Keep making questions in the WhatsApp group. I will keep sharing you the updates there. So just check the WhatsApp group at least once, twice a day when you are working, just to make sure that you are receiving all information. Yes, Hala.
Yeah, William, I just have a quick question regarding the test project. We said that the students should define the type of the connection, series or parallel of the total solar panels. He will
Yes.
decide it from the range and of the voltages and the current from the data sheet itself. How he will decide on this one? What is the proper procedure to define it?
Yes. Basically, what we have to look for in the data sheet, the minimum voltage of the operation of the inverter. Because let's say, for example, the minimum voltage that the inverter can work is 50 volts, and the solar panel is 30 volts. If you connect them all in parallel, you will not reach the voltage necessary for the inverter work. That's why they have to decide based on the inverter they choose for the project.
Okay,
Okay,
thank you, William. Thank
you're
you.
welcome. That's why.
Can it be series parallel? Combination.
Combination, I
Maybe.
don't think so.
Yeah, I don't think so, but
Mm.
yeah. This I will let you, based on your expertise, to decide it. Because if I
I-
say you that series is better, parallel is better, no one will think on it, and everybody will
I
give the
think
same answers.
William, I saw the specification for the inverter. The startup voltage is 100. So
Yes.
it should be series, right? Basically.
Yeah, based on this information, yeah.
I think, William, based on the calculations and the values, they will start it even from the calculation of the energy consumption and all the procedure for the energy, then to the battery, then to the inverter. I think the connection, the only way they will connect it is a series one, based on this type of inverters.
Okay.
Please
So-
correct me if I'm wrong.
I think
No,
that is the
this
answer.
information, yeah. I already informed you all the specifications of the project. It's a engineering decision. I will keep you because it's a competition, so you have to check.
Yeah.
You have to
Should
check what's
they-
the best.
Yeah, should each competitor should justify it, like explaining?
No,
Here will be the point and the difference between each competitor.
yes, if the student write a justification there, better because they will not be near me when I do the grading.
Yeah,
It's up to you.
like showing the averages of the current and voltage,
Yes,
and
no
then
problem.
showing that he decided this based on that. Even
Yeah.
if we know definitely it will be a serious connection.
Yes. By the way,
Right.
we are engineers. We know that as much as information possible we be able to give to the customer is better.
Yep.
I will not request that, but if they make a report and explain why, it's better for them. it will be more clear when I read their project.
Okay, perfect. Thank you, William.
You're welcome. But again, I will not look for it. If it's there, perfect. If it's not there, they will not be blamed for that. I will not deduct mark from them.
Okay, thank you.
Okay, you're welcome. More questions? No?
Just for me, Mr. William, to
Yeah, sure, let's
add
go.
me on Teams. I'm not added on Teams.
Oh, you are not
So
in Teams.
yeah, so I cannot see what's happening there.
Okay,
All of these.
I noticed that some of you, sometimes you are trying to read the share folder using a personal email in the Google or the browser you are using. That's why some of you are not reaching, because for me, here,
Yes,
uh,
here my name, yes.
yeah, the name is here for me in the group. Maybe when you are trying to reach the group, you are logged in your personal account. Most probably the problem is this.
Okay,
But
okay,
anyway, I'll share in the WhatsApp group. You will be able to see it anyway.
okay, thank you.
Okay, you're welcome. It's here. Okay, that's it. On my side, we are done.
Thank you, William.
Thank you very much. Let's keep working together. My position here is to guide you, provide you as much as possible with information and material for the competition. For again, we have a fair and fun competition for all competitors. They are the pop stars on this process. We are just the background, the backstage that will guide them through the process. Okay, so thank you very much. Have a nice weekend. I will send you the components, photos, and etc. Until Monday. And let's keep in touch on the WhatsApp. Thank you. Thank you.
Okay, thank you, William. Bye-bye.
Bye-bye.
والبيان